take a look at mutually exclusive and inclusive events. So go ahead and make a tab, entitle that, and then pause the video and copy all of this down. Never thought I'd get to open up full of craze. Traveling from the Gulf up through the States. Had a dream of rocking the mic at Flavor Fest. Shout out the crossover, yeah, I'm feeling blessed. So mutually exclusive, you can't get both events at the same time. It's one or the other, but not both. Inclusive, there's some overlap, and one thing can't happen without the other. When you see shapes like this, these are called Venn diagrams, and I'm going to explain how to read them and how to work them out. Okay, so it's one or the other, not both. This one has some overlap because you can see they intersect. Right, so if you're turning left or right, is that exclusive or inclusive? It's exclusive because you cannot do both. You're either going to turn left or you're going to turn right. What about a heads or tails? That's exclusive again because you could either have a heads or a tails. You cannot have both. How about kings and aces? That's exclusive again because you can either have a king or an ace. You can't have both. What about a king and a heart? Oh, wait a minute, I can have both because I can have a king of hearts, right? So that's inclusive. So that means there's going to be some overlap. Exclusive, there's no overlap. All right, so let's go ahead and draw in the kings and the aces. So you have a king of spades, a king of clubs, a king of hearts, and a king of diamonds. The listening check, put a box around Venn diagram and color it in. And same thing with the aces, the ace of clubs, ace of spades, the ace of hearts, and the ace of diamonds. And you can see there's nothing where there's in both. But when you look at inclusive, you can have a king of hearts. You put that in the middle because it's in both. So you put it on the overlap, king of hearts, because it's both in the kings and it's also in the hearts. And then the other kings would be not in the heart. So you have king of spades, a king of clubs, and a king of diamonds. Then you'd have an ace, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 of hearts. So again, the one that's in both is right in the middle because it's in both circles. The ones that are not in either one are in the circles that are by themselves. So kings and hearts, you can have both a king and a heart at the same time. That's why it's inclusive. So you need to know the difference between exclusive and inclusive. Inclusive, there's an overlap because you can have them at the same time. Alright, there's a formula for that. Okay, so what it is because it says what's probability of getting heads or kings, your or is adding them. But because there's an overlap, you have to subtract the overlap. When it's exclusive, it doesn't matter because there's no overlap. The overlap is 0. So let's take a look at an example. So you randomly choose one integer from 1 to 10. What's the probability that you get odd? Well, what are all the odd integers between 1 and 10? You've got 1, 3, 5, 7, and 9. So how many of those? Those are 5. Out of how many possible? Because it's what I want over possible. Out of 10. Probability that you get an even. So what are all the even numbers? 2, 4, 6, 8, and 10. And how many of those? 5, because that's what I want, over how many possible? 10. So probability you get odd or even. I see the word or, so I'm going to obviously add. And this is exclusive because it's not both, right? They're not telling me both. It's going to be 10 over 10, which is going to be 1. Now, does that answer make sense? Because 1 says it's for sure going to happen. This is a listening check. Color in the 2 circles with the odds and even numbers. Well, if I pick a number from 1 to 10, it will definitely be even or odd. Because there's no other numbers but even or odd. So of course that number makes sense. So remember, probability can only be between 0 and 1. It can't be negative. It can only be between 0 and 1. It can be 1.2. Alright, take a look at another example. So 2 fair dice are rolled. What's the probability that the sum is less than 7 or the probability the sum is exactly 10? Okay, so dice 1 has, you can either roll what, a 1, a 2, a 3, a 4, a 5, or 6. The second dice is the same thing. So let's make a kind of like a table thing so that we can understand what the sums are. So dice 1 on the top, dice 2 on the side, and then we're doing the sum because it's the probability of sum. So 1 plus 1 is 2. This is a listening check. Color in probability of sum is less than 7 in the question. 1 plus 2 is 3, 1 plus 3 is 4, and so forth. 2 plus 1 is 3, 2 plus 2 is 4, so forth. 3 plus 1 is 4. So we're just adding them together. 5 plus 1 is 6, 5 plus 2 is 7, 6 plus 1 is 7, so forth. Right, so these are all the possible sums I can get from rolling the dice. Probability that it's less than 7 is every number less than 7, not including 7, less than. So I've shaded in all the numbers that are less than 7. Probability that it's exactly 10, so shade in exactly what's 10. So you can see they're exclusive because there's no overlap, right? So the probability that you get less than 7 is you're going to count all these boxes, which is 15, over how many possible? It's 6 by 6, so 36. Plus, because it's OR, probability that's exactly 10 is 3 boxes, so 3 out of 36. Add those together, you get 18 over 36, which simplifies to a half, because you can divide both top and bottom by 18, which is 0.5 or 50%. This is exclusive. Again, exclusive, there's no overlap to one or the other. Let's take a look where there is an overlap. So we're choosing a club or a 10. So you can have either hearts, a diamond, spades, or clubs, right? And then the numbers go 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. So I'm not writing that for each one, so just draw arrows representing that it's in each one. Alright, so probability it's a club. So you have how many clubs? 12 clubs. Sorry, 13 clubs. I clearly can't count. Out of how many cards? 52. Or, which means I'm going to add the probability you get a 10. How many 10s are there in a deck? There are 4, because there are 4 of one of each kind out of a possible 52. Alright, now here's the thing. There is a club in there that's also a 10, which means we've counted it twice. We've counted it in the clubs and we've counted it in the 10. So we have to subtract that one. So it's a possibility of a club and a 10 is 1. There's 1 card in there out of 52. 13 plus 4 is 17 minus 1 is 16 over 52, which simplifies to 4 over 13, which is roughly 0.308 or 30.8%. This is inclusive because there's one that's both. There's an overlap. So it would look like the second Venn diagram because there's an overlap, a 10 of clubs. So sometimes it's a little bit faster to work backwards. So I want to show you what that means. Okay, so we have changed the question to what we don't want. We don't want a club or a 10. So I don't want a 10, so I'm going to cross that out. And I don't want a club, I'm going to cross that out. And then all that becomes now is I just count what's left. So you count everything of what's left. This is a listening check. Circle example 3. You get 36 out of a possible 52. Because each row has originally 13, but minus the 10s that we don't want, so makes 12. And then we subtract that number from 1, because 1 is the probability it definitely happens. So if I subtract what I don't want, I'm left with what I do want. I still get the 4 over 13 answer. So 2 ways you can do it. So let's look at another example. So choose a number from 1 to 10 that's less than 5 or odd. So let's have all the numbers. They go from 1 to 10. So write it down. 1 to 10. Alright, less than 5. Less than. So don't include 5. Probability that it's less than 5. What numbers are those? 4, 3, 2, 1. Plus, because it's OR, the probability that it's odd. Minus the probability that it's both. Because remember, an inclusive one, you have to subtract the ones that's both. So probability that it's less than 5, how many numbers are those? So I'm going to mark down what's less than 5. And I have 4 out of how many possible numbers? 10. So it's what I want over the total. Plus the probability that it's odd. So how many odds are there? So take a different color. How many odds? You have 5. That's what I want over total 10. Minus the probability that it's both of them. So you can see it's both 2 times. So 2 out of the possibility of 10. So 4 plus 5 is 9, minus 2 is 7. So if you do 7 divided by 10 in a calculator, you get 0.7. And then if you multiply the decimal by 100, you get the percent, which is 7. So let's work backwards. Choosing a number from 1 to 10 that's not less than 5 or odd. So not less than 5, so none of those. And not the odd ones, not the yellow. How many is left? 3. Out of how many? 10. Then you subtract that from 1, it give you 7 out of 10, because you want to subtract it what you don't want to get what you want. Which you can see is the same thing. This is a listening check. Color in inclusive, what I'm just writing down. It's so inclusive, you have to remember to subtract the common one. Okay, because exclusive, they're not going to be in common. Let's practice.